Hey guys, what's up? Today we're going to be doing the operational amplifier, and this is a really important device that's often used, and yeah, let's get right into it. So first we really want to look at the fundamentals of these devices, and to the right we can see, just to the top here, we can see I drew the operational amplifier, and these are just the wires that are pointing into them. And what's really important to note is that there's never going to be any current going into the amplifier. And the voltage at one end of the amplifier is always going to be equal to the voltage at the other end of the amplifier. So really, this makes it so that in almost any example, we really want to always just find the voltages at each end of the amplifier first, because that'll give us a pretty good lead to solve the circuit. So for the circuit to our left, we're tasked with finding the current labeled I and the output voltage labeled V0. And how are we going to do this? It looks like a pretty complex circuit for a beginner, but what we can first do is, when we look at the amplifier, we see we don't have the voltages at each end. So let's go ahead and find that and see if that helps with anything. So since we know that there's zero current going in, we can almost label this what I just circled there. Sorry, let's actually do that in a better color. Let's pick green. So you can see in this little wire that I circled here, since there's no current going to the amplifier, this entire wire is going to share the exact same current. It's technically just going to be sort of like a wire like this with an 11 ohm resistance. And that should be pretty obvious. So essentially what we can do, let's first find our voltage. So we know that the voltage at this end here, we'll label this Vx and Vx. So we know that Vx, we see there's a 19 volt source and then 6 ohm resistance and a 9 ohm resistance. Since there's 0 amps, we can kind of treat this like as if this wire that I'm about to outline in blue, as if that just isn't even there. So it's just a simple series circuit with a 6 and a 9 ohm voltage 6 and 9 ohm resistances. So the easiest way we can do this is to simply do a voltage divider. So Vx, and we know that it's going to be the voltage across the 9 ohm resistance. And why do we know that? Because what Vx is the voltage after the voltage drop across the 6 ohm resistance. Now don't forget that the voltage across the resistance symbolizes how much voltage you're going to be losing. That often confuses people, I find. So what we can do is 9 multiplied by 19 volts ohms over 6 ohms plus 9 ohms. And Vx, this gives us a Vx of 11.4 volts. So we now know Vx is 11.4 volts. And remember how we talked about we can treat this wire as it shares the same current. So what we can do is, let's label this in blue. We can find the current going down here, and then in the red, we can find the current through here as well. Or once we find that current, we know the current through the red, so we can find what our V0 is, because this right here is also going to be V0. So let's find what the current in blue is. So we know that I is equal to the voltage divided by the resistance. So we can simply do Vx over 5. So that'll be 11.4 volts over 5 ohms. And that's going to give us a current of simply 2.28 amps. Sweet. So we have the current now, and that's going to be the same current for the red arrow. So if we do another current formula, I equals V over R, we want to find V naught. So we can write this as 2.28, because we know they share the same current, is equivalent to V naught minus Vx, which is 11.4 over 6 ohms, and this is amps right here. So now once we simplify this, we find the current is going to be simply equal to, we find the output voltage is going to be equal to 25.08 volts. Simple as that, and now we have that voltage. We have V out. We completed that. Let's check that. So now all we have to do is we have to find I, the current leaving the amplifier. And so all we have to do here is perform a basic KCL. We have the current going through the wire outlined in green, and we can easily find the current going down this path because we know the voltage and we know the resistance. So when we do a KCL at V naught, we get I is equal to V naught over 9 plus 2.28 amps, which we found that to be earlier on. And now we can simply plug in V naught as 25.08 over 9 plus 2.28, and that gives us a voltage of 5.06 amps. Circle that, and let's circle our output voltage. It's really as simple as that, guys. Operational amplifiers, they're a pretty easy task. If you do practice, you'll definitely get the hang of them and understand how to solve many more. This, I honestly think, is the hardest one, so if you understand this one, you should be good to go for the rest of them. Thank you so much for watching, and I hope you all learned something.